Okay, let's get started. My name is Felipe Narciso, and today with my colleague Edwin, Aditya, and Carlos, we will present results of our senior design project. Right now, I'm going to pass to Carlos to get started with the objectives.
Thank you, Philippe. So for our project, our main objective given to us by Clarion was to find a collector that is going to help us in their task. Currently, they have an average collector, which gives them about average copper recovery and very high iron recovery. What they're looking for is something that can either increase the amount of copper recovered or decrease the amount of iron recovered, to therefore give us a higher concentration in their final product. To do this, we were tasked to perform 5 different flotation tests, each with a different variable. And from there, we were to analyze the results and see which collector would be the most efficient. To elaborate more on this, on the flotation test, I'm going to pass it back to Philippe.
Thank you, Carlos. Just to give a little bit of context on flotation process. So it's a process that takes advantage of the hydrophobic properties of minerals. So the idea is that we float the valuable minerals while we suppress the non-valuable. So in this process, we have like a flotation cells where we have the medium being water, and that is where we have our product of the grinding. And then at the end, we have our final concentrate. That's where we make our analysis to see the content of valuable mineral and the content of non-valuable. So to give more information on that, I'm going to pass to Edwin.
Thank you, Philippe. So doing the testing, what we had to do was we had to do 5 different flotation tests. And doing the experiment, we had to make sure that the pH was at 10.5 at all times. And we were presented with 2 collectors. One was a standard collector and another was a collector from Clarion. And we had to use both collectors doing the testing. With those collectors, we use some of the flotation tests using those standard collector, and also we did some of the flotation tests using those Clarion collectors. And at the end of the day, what we had to do was we gather those numbers and compare them to see how well those numbers perform during the flotation. So during the testing, these were the procedures we use. First, we had to make sure we prepare our sample. And sample preparation is where we had to do our sequential copper analysis. And also we had to make sure we measure the concentration of our chemical used during the testing. Secondly, what we had to do was do test charges. Next, we had to grind our sample. And then we had to do the flotation test, as my colleague discussed earlier. And then during the flotation test, we had to make sure we separate the concentrate from the tails. And then afterward, we had to do pulverization, digestion, and AA analysis. As you can see in the picture below, those are picture taken showing my colleagues doing those experiments. With that, I'm going to pass it on my colleague, Philippe, to continue.
Thank you, Edwin. So here we have our results. So those are what we got from performing the AA analysis, the atomic absorption spectroscopy. So basically we had the final concentrate, and then we analyzed the final content of copper and the final content of iron. So here, this graph shows the recovery of copper as a function of flotation time, while here we have the iron as a function of flotation time. What we see here is the blue line here is the past where only the commercial standard collector were used, the PAX and BTP. And the other 4 tests, that's where the Clarion collector were employed. And as we can see, we don't see much of a difference in terms of efficiency, just slightly. When we jump to the iron recovery and flotation time, we see another trend. What we see is here, the standard collector present a much higher recovery, while the Clarion collector, they show a much lower recovery. To have a little bit more discussion on that, I'm going to pass to Aditya, who will continue with the development of the results.
Thank you, Philippe. So as Philippe was talking about earlier, if we look at the copper recovery and flotation time graph, we realize that the copper recovery is nearly the same for all the collectors, the standard collectors, PAX and DTP, and the two new collectors in question. But we see a change when we look at the iron recovery graph. When we look at iron recovery for the new collectors, the iron recovery reduces from 80% to 50% as compared to the original collectors. So we see a big decrease in the recovery of iron, which clearly shows that the new collectors are actually very efficient in suppressing pyrite while flotation of copper. So based on these two factors, the same amount of copper recovery and decreased iron recovery, we come to the conclusion that the two new collectors in use are actually more favorable than PAX and DTP, which were used in before. So our recommendation would be to use the two new collectors instead of PAX and DTP. With that, I'd like to pass on to Philippe for the closing remarks.
All right, so we came to the conclusion of our presentation. I think it's reasonable to highlight that indeed we met our objective. We have two collectors and they do a much better job in terms of, lowering the recovery of iron while keeping the same level or improving the recovery of copper. So the challenge that we have in front of us is now trying to convince the mineral processing industry that we have a better solution. There is a better solution. That is the Osterflot 117, 7145 and 146. And so it's not going to be an easy job because, PAX has been the only, collector being used. So, but now with those numbers, with those results, we can prove that, that is a much better solution. So before we end, we would like to give a recognition to our sponsor, Current Mining Solution, for the tremendous support that they gave to us throughout the 2 semesters. And also we would like to also recognize our mentor, Dr. Brad Ross, for his mentorship, because without his mentorship, we wouldn't, this presentation wouldn't be as successful as it is right now. And also thank you to everyone that is listening to us in this presentation. And that's all what we have today. And I hope you have enjoyed this presentation. Thank you.
Thank you.
Thank you.